All right, let's try another example. So example number 2, we have 4 to the 2t plus 1 is equal to 16. Remember, when you are solving these, you first need to figure out if you have an exponential or a logarithmic function. And here we have an exponential function because we have our variable in the exponent. So exponential function. Which means that we need to get the exponential piece by itself, and then we'll wind up using a log. Okay, so we have 4 to the 2t plus 1 equal to 16. I need to get rid of that 1 first, so I'm going to subtract. We have 4 to the 2t is equal to 15, and this is where I have my exponential piece by itself, and there's no way that we're going to rewrite as 15 as 4 to a power or 2 to a power, which is how I know I need to use logs. Remember, you can use log or natural log. Those are the ones in our calculators readily available. I'm going to use natural log. That's just my favorite. You can use common log, log base 10 if you'd like. But we're going to take log or natural log of both sides. Remember, you cannot mix and match, so you can't have ln on one side and log on the other. But the whole reason we do this step is so that we can bring that exponent all the way down. Bringing it down, we now have 2t out front, natural log of 4, equal to the natural log of 15. Keep in mind that we are solving for t. We have all of this stuff together with the t. We have 2 times t natural log of 4. So really, we are multiplying by both t and natural log of 4. So what we're going to do is divide both sides of our equation by 2 natural log of 4. The 2's will cancel because 2 divided by 2 is 1. And the natural log of 4's will cancel because natural log of 4 divided by natural log of 4 is also 1. So on the left-hand side, we have t. And on the right-hand side, we have the natural log of 15 all over 2 natural log of 4. You need to make sure that that 2 stays in the denominator along with that natural log of 4. This guy, since we have t completely by itself, is our exact answer. Okay. We need the decimal approximation. I'm going to use my handy dandy app or website, desmos.com. I'm using the graphing because I don't want to have to go back and forth between the graphing and scientific. Okay, so clicking in, we're going to go down and get our little keypad. Remember that we need to set up our division first, so we get our fraction, and we need our natural log. You could technically type in ln if you really want to, but that's not really necessary because we have the log function under functions. We're going to scroll down to the calculus section. We need our natural log. We said we were doing natural log of 15. Close our parentheses. All over 2 natural log of 4. and we get our decimal approximation. Remember, if you were to use common log, log base 10, you will get to the same answer. You would have log of 15 all over 2 log of 4. And we get to the same answer. Okay, so for our decimal approximation, we need to go to 4 decimal places. We have that t is equal to 0.97672, because we always look at one more place than we need. So if we're going to 4, we have to look at the 5th. Remember, to round up, you need to be 5 or more. So that's not enough to get us anywhere. And our decimal approximation is t equal to 0.9767.